This question is about the locus. You may not need to calculate what exactly the locus of P, but at least you need to know the shape of the locus of P. And then to do this, there are two straight lines. And then there is a moving point P such that the moving point to the first line and the second line have the same distance. And then how is the locus of P look like? In this kind of question is a very important part is you realize the coefficient ratio of x and y term. 2 to 3, 4 to 6 are basically the same, which means that they have the same slope. If they have the different slope, then the answer will be totally different. So the slope here for L1, change the equation 3y equal negative 2x plus 5. So y is equal to negative 2 over 3x plus 5 over 3. So we know that the slope is negative 2 over 3. L1 is approximately like this. This is 5 over 3. And then going downward. Similarly, L2 we do the same. 4x plus 6y equal to 7. So after we simplify that, we find out that the slope are the same. That's why we say that the ratio of their coefficient will show you the slope. So 7 over 6 is smaller. They are parallel. So now, if you can think about the locus of P, some point, so that they're in the middle. So of course I will think this one. So the red line is the locus of P. So of course it's a straight line. If you realize that the L1 and L2 have the same slope, then you can solve it within a shorter time. But one thing I would like to remind you is how about if L1 and L2 are not parallel. For example, let's say L1 is like this, L2 is like this. Then you'll find that P may along this line such that it's always between L1 and L2. But not only this line, also another direction. So you'll find that the locus of P may be on this line, may be on this line. Then we say that we describe the locus of P as a pair of straight line. A pair of straight line, not only one line, but it's formed two lines here. But in this case, if they give you the same slope, then just one straight line.